Welcome to the Automated Daily Space News Edition, the podcast created by generative AI. Imagine looking across the Martian surface and seeing an almost endless carpet of geometric patterns etched into ancient rock. Today, we will talk about what that might mean for the planet's long-lost climate. Today is August 19th, 2026, and I'm Trent Teller, here with a calm, focused look at the most interesting space and astronomy stories from the last 24 hours. We will move from Mars and dying stars to future telescopes, quantum tricks, and a busy launch pad, keeping the emphasis on what happened and why it matters, rather than getting lost in technical details. So let's dive in and see how the universe has been changing while we go about our day. This episode is brought to you by Lindy. Lindy is your ultimate AI assistant that proactively manages your inbox, meetings, and calendar so you can focus on what actually matters. Find the link in the episode notes. Our first story takes us to Gale Crater on Mars, where NASA's Curiosity rover has sent back images of a landscape covered in small, polygon-shaped patterns that caught scientists completely off guard. These features look like a sea of interlocking cracks, each roughly a few centimeters across, and they resemble the sort of mud polygons that form when wet ground repeatedly dries out and fractures. Previous work in Gale Crater suggested similar mud cracks formed during intense wet-dry cycles around 3.8 to 3.6 billion years ago, a period when Mars may have had a climate closer to early Earth, with standing water and active hydrological processes. The newly imaged field is striking because of its extent and regularity, and mission scientist Ashwin Vasavada described the view as breathtaking, noting that careful measurements of their shapes and chemistry could reveal whether they indeed mark ancient shorelines or lake beds that dried again and again. If that interpretation holds up, these polygons would strengthen the case that early Mars went through repeated episodes of liquid water and evaporation, conditions that many astrobiologists consider promising for prebiotic chemistry and potential habitats for microbial life. From the red planet, we move to a dying star in our cosmic backyard, the Helix Nebula, which has become a testbed for a new telescope array called MOTHRA in Chile. Astronomers used early observations from this array to capture extraordinarily detailed images of the helix and found at least 22 glowing shockwaves where debris from the star is smashing into the surrounding interstellar gas. Each of these bow shocks marks a place where fast-moving stellar fragments plow into slower material, heating and compressing it, and together they outline how the nebula is reshaping and recycling the products of stellar death back into the broader galactic environment. The team estimates that these individual fragments only remain intact for about 10,000 years after they collide with the gas, which is short on cosmic timescales and underscores how quickly the visible structures in a nebula can evolve. Seeing so many shocks at once gives astrophysicists a rare laboratory for testing models of how dying stars shed their outer layers and enrich the interstellar medium with heavier elements, material that will eventually be incorporated into new generations of stars and planets. It is a vivid reminder that the elements making up planets and us are constantly being cycled through birth and death of stars. Looking ahead rather than backward, astronomers are starting to focus on the Habitable Worlds Observatory, a planned space telescope designed with one central ambition: to directly image Earth-like exoplanets around nearby stars. Unlike current missions that infer planets from transits or subtle wobbles, this observatory aims to suppress starlight enough to pick out the faint glow of a small rocky world in a habitable zone, opening the door to detailed studies of its atmosphere. That means looking for spectral fingerprints of gases such as oxygen, methane, and water vapor, which in certain combinations could signal biological activity, though scientists are careful to stress that many of these gases also have non-biological sources. The key point in the latest coverage is that the mission is being engineered very deliberately around this single goal, with its design, optics, and observing strategy all tuned to maximize the chances of spotting a truly Earth-like planet. While it will not fly for years, the way researchers frame it shows a shift in exoplanet science, moving from simply counting worlds to building a machine that can tell us with much more confidence whether any of them look like home. There's also news on the gravitational wave frontier, where researchers are exploring a quantum trick that could sharpen our ability to detect ripples in space-time. Traditional gravitational wave detectors rely on exquisitely precise measurements of laser light bouncing between mirrors, but they are limited by quantum noise, the fundamental fuzziness in those light fields. The new proposal, highlighted in recent reporting, suggests using clever manipulation of quantum states to reduce that noise and thereby boost sensitivity, allowing detectors to pick up weaker or more distant events. While the work is still theoretical and very technical under the hood, the underlying message is straightforward. By letting quantum mechanics work for us rather than against us, we might expand the volume of the universe we can survey for black hole and neutron star mergers. That would mean a richer catalog of gravitational wave sources, tighter constraints on models of compact objects, and potentially better measurements of how fast the universe is expanding, since these events can serve as so-called standard sirens. It is an incremental story rather than a dramatic discovery, but it illustrates how fundamental physics continues to quietly reshape the tools we use to listen to the cosmos. Now to low Earth orbit, where SpaceX has just launched its 100th mission of the year 2026, sending another 24 Starlink broadband satellites into space from Vandenberg Space Force Base in California. The Falcon 9 lifted off at 12:01 a.m. Eastern Time, and after a short ride to orbit, the upper stage deployed the satellites while the first stage booster flew back down to the Pacific to land on the drone ship Of Course I Still Love You. This particular booster, designated B1097, has now flown 12 times, reflecting how deeply reusability has become for the company's operations. The mission itself pushed the active Starlink constellation to a little over 11,000 satellites, a number that includes spacecraft in various states of operation and deorbit, and marks another step in the rapid buildup of global coverage. The significance here is twofold. On one hand, this kind of launch cadence and reuse is redefining what is considered normal in orbital access, and on the other, such a dense mega-constellation raises ongoing questions about space traffic management, debris risk, and the long-term sustainability of low Earth orbit. For now, the focus is on the milestone, showing how quickly a single operator can scale both hardware and infrastructure when their system is mature. Space activity is not just about one company, though, and there is important news out of China's commercial sector, where Land Space Technology Corporation's Zhuku 3 rocket has completed its second flight and achieved a successful first-stage landing. Zhuku 3 is a medium-lift, methane-fueled launcher with dimensions and performance broadly comparable to a Falcon 9 class vehicle, and like that rocket, it is designed for partial reusability. Liftoff took place from the Zhuquan Satellite Launch Center in the Gobi Desert, and for this test flight, the company attempted to land the booster on a pad roughly 300 kilometers downrange, a maneuver that failed on the first flight in late 2025 when the stage crossed just meters from the target. This time, early reports indicate that the landing was successful, marking a major technical milestone for the company and for China's growing ecosystem of private space firms. No payloads were publicly confirmed, underscoring that the main objective was to demonstrate the reusability architecture rather than deliver commercial satellites. In a broader context, this flight shows that methane-fueled reusable rockets are no longer the exclusive domain of a small number of Western operators, and that the race to lower the cost of access to space is truly global. While rockets take off and land, astronauts continue the quieter, methodical work of keeping orbital infrastructure running, and the International Space Station was the scene of a notable spacewalk on August 18th. NASA astronaut Anil Menon and European Space Agency astronaut Sophie Adenot exited the station's Quest airlock to replace a high-speed space-to-ground communications antenna, a critical link that carries data between the station and mission control in Houston. The spacewalk, designated U.S. Spacewalk 97, was expected to last about 6.5 hours, with Menon serving as crew member 1 and Adenot as crew member 2. For Adenot, this was her first spacewalk, and it made her the first French woman ever to perform an extravehicular activity, a symbolic milestone for European human spaceflight. The practical outcome is equally important. By swapping out the antenna, the crew helps ensure that large volumes of science data, systems telemetry, and high-definition video can continue to flow reliably between the ISS and the ground. The event was streamed live on NASA platforms, giving the public a real-time look at the kind of maintenance and upgrade work that rarely makes headlines, but is essential for keeping a multinational orbital laboratory functioning. Thanks to our sponsor, Stock MVP. Stock MVP helps you invest like the pros using data-driven insights. Find the link in the episode notes. That wraps up today's journey through the latest in planetary science, stellar death, future observatories, quantum ideas, and the very practical business of getting hardware and humans into space. We started with an ancient Martian landscape, frozen into polygons that may record long-gone wet seasons, and ended with a modern space station where astronauts quietly keep our link to orbit alive. Along the way, we saw how new telescopes like MOTHRA are revealing the fine structure of nebulae, how mission planners are sharpening their focus on habitable worlds, and how both quantum physics and rocket reusability are steadily changing the tools we use to explore the cosmos. As always, the theme is continuity. Yesterday's dying stars seed tomorrow's planets, and today's engineering advances set the stage for discoveries that will come years from now. If you enjoyed this calm, fact-focused tour of space news, consider sharing the automated daily space news edition with a friend who likes to stay grounded while looking up. I'm Trent Teller, thanks for listening, and I'll be back with more verified stories from the universe soon.